Let's try to evaluate all of these integrals using substitution. The first one, x times square root of x squared minus 1. We're going to let x squared minus 1 be our u. So our u prime is 2x, so you want to have 2 out front, and this thing is telling you you should divide by 2. So we have 1/2 times integral of square root of u du. Because we can ignore u prime, all we have is basically square root of u with respect to u. And this thing becomes, that's u to the 1/2. So you're going to add 1 to it, which gets you 3/2. And you're going to divide by the same thing, plus c. And dividing by 3/2 is the same thing as multiplying by 2/3. So these 2's cancel out. So you have 1/3 u to the 3/2 plus c. And our u was x squared minus 1. So we have 1/3 x squared minus 1 to the 3/2 plus c. So that's our first one. Let's look at our second one. Integral of dx over square root of 3x plus 1. In this case, our u is 3x plus 1. So our u prime is 3. So you're going to multiply by 3, divide by 1/3. Now you can ignore our u prime, and this thing becomes 1/3 du over square root of u. This thing is square root of u, and we can ignore our u prime and turn this into du. And this thing is same thing as u to the negative 1/2. So you're going to add 1 to it, which gets you u to the 1/2. Divide by the same thing. So dividing by 1/2 is same thing as multiplying by 2. So you have 2/3 times u to the 1/2 or square root of u, which in this case is 3x plus 1 plus c. The last one, x times cosine of x squared dx. In this case, our u is x squared, so our u prime is 2x. So let's divide by 2. And we have 1/2 integral of cosine of u du. We can ignore our u prime and turn this into du. So we have what's integral of cosine. What do we have to differentiate to get cosine? That's sine. So we have 1/2 times sine of u, and our u was x squared. So 1/2 sine of x squared plus c. And then